Bismillahirrahmanirrahim. Dear students, today we are going to start a very important chapter of the second year chemistry, which is the chapter number 19, and that is about the aldehydes and ketones. So in this lecture, I will discuss about the nomenclature of the aldehydes and ketones, and then we will discuss the various methods for their preparations. So in previous lectures, we discussed various classes of the organic compounds, and today we are going to discuss a new class, and that is the class of organic compound which contains the carbonyl group as the functional group. So this C double bond O, this is called as the carbonyl group, and those organic compounds which contains the carbonyl group, they are called as the carbonyl compounds. So we can see this carbon is making a double bond with the oxygen, and these two bonds are remaining. So if on one side of this carbonyl there is a must hydrogen, so there will be at least one hydrogen on one side of the carbonyl, that class is called as the aldehydes. And if on both sides of the carbonyl these are the carbons, so that will called as the ketones. So this is its structure or the condensed formula. This is RCHO, and that is RCOR. So these are the class of organic compounds which have the carbonyl group, and these are called as the carbonyl compounds. So they might be aldehyde, they might be the ketone. So organic compounds containing the carbonyl functional group are called aldehydes and ketones. And this is a simple comparison between the aldehydes as well as the ketone. So if we discuss about the functional group, so in aldehydes, the carbon atom of the carbonyl group is directly attached to at least one hydrogen atom. In ketones, the carbon atom of the carbonyl group is bonded to two carbon atoms called ketone group. And if we discuss the general formula, so both have same general formula, CnH2nO and CnH2nO. And the general structure of this aldehyde, this is a C double bond O and this is the H. So this is represented by R, C double bond O and H, and the ketone, they are represented by R, C double bond O and R. Aldehydes groups are present in most sugars. They are principal constituent of a number of essential oils used as fragrances and flavors. Ketone group is present in the camphor and fructose. So fructose and glucose, we know these are different forms. Generally, this is formaldehyde. Simplest example of the aldehyde. This is formaldehyde. So this CHO is the functional group, and H is the minimum H is attached. So this is the simplest molecule, formaldehyde, and this is the acetaldehyde. This is the simplest ketone, so acetone, that is methyl ethyl ketone. Nomenclature, we know that we have various kinds of naming, common name as well as the IUPAC names. So we use the word aldehyde before the name of the carbon atoms. So this is the simplest aldehyde, C double bond O and H. So this is formyl group, and they have another hydrogen. So this is the simplest aldehyde, that is called formaldehyde. Because this formaldehyde is oxidized to make the formic acid, mean the carboxylic acid. So we use this word derived from the carboxylic acid. And we use the word aldehyde. This is formaldehyde. So this is the next homologue of that. This is CH3. This is called as the acetaldehyde. Similarly, if they have some substituents, this is carbon, this is our functional group, and that carbon which is attached to functional group, that is called as the alpha carbon, and next is called as the beta carbon. So at the alpha, this is the methyl, so its name will be alpha methyl propione aldehyde. Similarly, this is alpha, this is the beta, this is the gamma. So at the beta position we have the chlorine, so its name will be beta chlorobutyryl aldehyde. If we go to the IUPAC system, we select the longest chain of the aldehyde group is taken as the parent hydrocarbon, So we will number from that side where the aldehyde group is start of the chain, and we use the word, we replace the word of the alkane E with the Al. For example, we have the one carbon and that is the aldehyde, that is called as methane al. Similarly, just like the alcohol, methanol, methanol, or we use the word methanol mean one carbon alcohol. So methanal, one carbon aldehyde, ethanal, two carbon aldehyde, propanal, three carbon aldehyde, and aldehyde group will get the carbon number 1 because that will be at the edge of the chain. So this is 1, 2 and 3. So this is 3 carbon aldehyde. So its name will be propanal. So if we go to this one, this is 1 and 2. So at the 2 number we have the chlorine. Its name will be 2-chloroethanol. Similarly, carbon number 1, carbon number 2, 3, 4 and 5. So at the 3 position we have the bromo branch, and the 4 position we have the methyl. So its name will be 3-bromo, 4-methyl pentanal. Similarly for the ketone, so we use the word ketone. So just like the ether, dimethyl ether. So this is the ketone. So this is simplest ketone. This is dimethyl ketone, and it is generally called as acetone. So its name will be, this is methyl, this is the ethyl. So its name will be ethyl methyl ketone. And similarly, if we have the substituent, so this is the carbon which is attached to the functional group, that is alpha carbon. So at the alpha, this is the methyl. Otherwise, this is ethyl and this is a methyl. So its name will be methyl. This one the methyl, alpha methyl, ethyl and ketone. Similarly, this is alpha, beta and this is the chlorine. So this is the methyl, beta chloro, ethyl, ketone. If we go to the IUPAC system, so we use the word on for these ketones. So for example, we will number from that side where this ketonic group is the nearest, because that cardinal will be in the middle of the chain, so inside the chain. So it will be not on the edge, because if this is on the edge, then this will change into the aldehyde group. So now this is carbon number 1, carbon number 2, carbon number 3 and carbon number 4. It means this is 4 carbon chain. So this is pentane, and they contain the ketone. So its name will be pentane. This is 4 carbon chain. So this is butaneone. And because this is at the second number, so its name will be 2-butaneone. So we replace the word butane E with one. So this new way is butane 2-one. Similarly, this one we select the longest chain 1, 2, 3, 4 and 5. It means this is 3-pentanone. But on the second number carbon as well as at the 4 number carbon we have the branches. So its name will be 2,4 dimethyl 3-pentaneone. Over this side, so this is carbon number 1. So this is the phenyl group. So this is 1 phenyl, 1 propanone. Similarly, this is the cyclic system. So 1, 2, 3. So this is 3-methyl cyclopentaneone. So this is 1, 2 and 3. So this is basically this is cyclohexene. So its name will be 2-cyclohexeneone. This one another bigger molecule. So 1, 2, 3, 4 and 5. So at the 4 number position we have the hydroxy as well as the methyl as the branch. So its name will be 4-hydroxy, 4-methyl, 2-pentaneone. Now come to their physical properties. We know the carbonyl group, C double bond. So this is a polar. This is a polar group. So oxygen electronegativity is more as compared to carbon. So oxygen will get the partial negative charge and carbon will get the partial positive charge. So due to difference in the electronegativity, this carbonyl group is a polar. So that's why these aldehydes and ketone molecules, they have dipole-dipole interaction with each other. And they cannot make the hydrogen bond with each other. So one aldehyde molecule and second aldehyde molecule, they have a dipole-dipole forces. But they can make hydrogen bond with other hydrogen donor molecule, for example water as well as the alcohol. It means aldehydes and ketones, they can make hydrogen bond with the water as well as the alcohols. So the implications of these effects, higher melting and boiling points compared to the analogous alkanes. So they have higher melting point and boiling points as compared to the alkane because of dipole-dipole forces. Lower boiling points than alcohols because the alcohols they have the hydrogen bonding, but aldehydes, ketones they have the dipole-dipole forces. That's why their boiling points will be low. More soluble than alkane but less soluble than alcohol and aqueous media because alcohol molecule itself they have a hydrogen bonding and they make the hydrogen bonding with the water, but the aldehydes and ketones they have dipole forces, so they will make hydrogen bonding with water, so they are more soluble than alkane because alkanes are non-polar, so they are not going to make any interaction with the water molecule. So we are going to discuss very important part of this lecture, that is the preparations of aldehydes and ketones. So these aldehydes and ketones can be prepared by various methods. So out of that, this is the summary of four types or the four ways in which we can make the aldehydes as well as the ketones. And these all methods, they are all discussed in the previous lectures. So this is only revision, you can say this is the revision of all those lectures. So ozonolysis of the alkene. So mean reaction of alkene with the ozone. So when we react with the ozone, this bond cleaves and we get two carbonyl compounds. So it depends on the groups which are attached over here. So it might change to aldehyde or the ketone. Secondly, we can also make the carbonyl compounds by hydration of the alkyne. It means when we add water into the alkyne in the presence of H2SO4, HgSO4, first it converts into vinyl alcohol like this one, and then it undergo rearrangement and we get the ketones or the aldehyde. Similarly, aldehydes can be prepared by the oxidation of the primary alcohol. So primary alcohol means the carbon which is attached to OH has two hydrogen or directly linked with one carbon. So if we oxidize that primary alcohol, it will convert into aldehyde. And that aldehyde is further oxidized to make the carboxylic acid. Or the aromatic aldehydes and aromatic ketones can be prepared by the reaction of the benzene with acyl chloride. So this is Friedel-Crafts acylation in the presence of AlCl3 and we get the aromatic ketones. So these are the various methods which we can prepare, we can use for the preparation of aldehydes as well as ketone, and we will discuss these methods in detail in the next slides. So in the first slide, this is the ozonolysis of the alkene. So this is a general reaction with the ozone. So this bond breaks and we get the two carbonyl compounds. So this reaction takes through some kind of mechanism. So first this alkene molecule add this ozone and convert into this one. This is called monozonide. And now this undergo rearrangement to make this another intermediate that is called ozonide. And that is the stable one. And now it reacts with water and this bond breaks. So this is called as a workup. This bond breaks and we get two molecules of the formaldehyde and H2O2. Now this is reduced with zinc and converted to zinc oxide as well as the water. So if these are the hydrogens, so we will get the aldehyde. If these are some carbon, we will get the ketone. So this is the first method in which we convert the alkene into the carbonyl compounds, either aldehyde, either ketone by the ozonolysis. Secondly, alkynes. We can add the water into alkyne and we can get the aldehyde as well as the ketone. But if we have the acetylene, this is simplest alkyne. So this is the simplest alkyne. So if we add the water, so this water is unsymmetrical. So H and OH. So in one carbon H will add and in the second carbon this OH will add. So we will convert this CH into CH2 and this triple bond will change to double bond and CH and OH. And this reaction takes place in the presence of H2SO4 and HgSO4. And this is called as a vinyl alcohol. And now this vinyl alcohol undergoes some kind of rearrangement, just like ketoenol tautomerism. So this bond shift over here, and these two electrons move to this carbon. So this hydrogen is moved from oxygen and it will attach to this carbon. So now the change will be CH3 single bond, C double bond O and H. So this is acetaldehyde. So that is called as tautomerism, rearrangement. So this is tautomerism. So this is a shift of proton from one atom to another atom within the same molecule. So this is called acetaldehyde. So for the acetylene, the addition of water, we get the acetaldehyde. So there might be a short question, how you convert acetylene into acetaldehyde or ethanol. This is ethanol. But similarly, if we add water into the higher alkynes, for example propine. So if we add water into the propine, now this is unsymmetrical, and this H and OH. So this addition will take place according to Marconi-Karp rule. So the negative part of this reagent will go to that carbon which has less number of hydrogen. So this OH will go to this carbon, and H will go to this carbon, and triple bond will be changed to the double bond. And now in the same way, the rearrangement, this proton is moving from oxygen to this hydrogen, and this double bond is shifting over here. No, so the change will be CH3, C double bond O and CH3. So this is the acetone. So we can say in a summary that the addition of water in ethyne, we get the acetaldehyde. Addition of water in the higher alkynes, we will get the ketones. So only we will get the aldehyde in case of ethyne, and in case of higher alkyne we will get the ketone. So will be a paper question that how you convert alkynes into aldehydes as well as the ketone. So we will use various examples to convert aldehyde into the ketones. Similarly, this is the methyl. This is the phenyl acetylene. And similarly, so this is addition of water. So OH will go to this carbon, and this will rearrange, and we will get this is called the acetophenone. So if this acetyl group is attached, this is called the acetophenone. So this is the another method for the conversion of phenyl acetylene into acetophenone. So as we said that the aldehydes can be prepared by the oxidation. So primary alcohols, they will oxidize to make the aldehydes, and secondary alcohol will oxidize to make the ketone. So this is the reagent we will use for the oxidation, and this is called the oxidizing agents which will cause the oxidation. So this is the concentrated sulfuric acid, sodium dichromate, and this is called as Jones reagent. And we said that this, in the presence of this Jones reagent, this aldehyde is further oxidized to make the acid. So for that purpose we use some mild reagent. So this is the Seret reagent which will convert the alcohol into the aldehyde. Similarly, this is another example. So this is the alcohol into the aldehyde. So this Jones reagent will convert, this is a secondary alcohol. So this secondary alcohol will convert into the ketone. Now come to the last method, Friedel-Crafts acylation of the benzene. So if this is the benzene, it reacts with the acetyl chloride. So in the presence of AlCl3, so this part will attach. So this will be C6H5, C double bond O and Cl. So this is alkyl, aryl and ketone. So this is the Friedel-Crafts alkylation we discussed in the chapter of the benzene. So for example, and we know in the presence of this AlCl3, first of all this electrophile is produced, acetylene, this electrophile is produced, and it attacks on the benzene ring, and we will get the ketones. So if this is the methyl, so we will get the methyl over here. This is called as the acetophenone. And if this is the benzene ring, so we will have another benzene over here. So that will called as the benzophenone. So if I make the summary of today's lecture, we discussed two important topics of the aldehydes and ketones. First, we discussed the nomenclature of the aldehydes and ketones, and then we move toward its various methods of the preparations. So if you have any question, you can send us in the comment box. We will discuss about that. Thanks and good luck.